Okay, so now we're working on our very last section in chapter 3, and we're going to talk about sequences and how this relates to our functions and our tables and our mappings and all that sort of stuff. And it is really all related. So our sequence is really a list of numbers. And that list of numbers are going to form a pattern. Now, every number in the sequence is called a term. Now, we're going to look specifically at arithmetic sequences in this chapter. And with arithmetic sequences, there's a common difference between the terms. So every time I'm adding the same number, or every time I'm subtracting the same number, and we kind of saw this pattern when we were working on tables earlier in the chapter. And we're actually going to use tables to help us write an equation for our arithmetic sequence. So we're going to go ahead and look at these examples and determine if the sequence is an arithmetic sequence. So we're looking for a common difference. We're looking at what we're adding each time and deciding if it's a arithmetic sequence or not. So when I'm looking at my first term to my second term, it looks like I'm adding 0.2. And then I add 0.2. And then I add 0.2. So this is arithmetic sequence because I'm always adding 0.2 to get to the next value. Okay, so let's look at the next one. So if I'm going from 9 to 13, I'm adding 4. 13 to 17, I'm adding 4. 17 to 21, I'm adding 4. So each time I add 4. So yes, this is an arithmetic sequence. And our common difference is 4. Now we're going to look at our next one. So I'm going from 10 to 8, so I'm subtracting 2, then subtracting 3, and then subtracting 4. So subtract 2, subtract 3, subtract 4. I'm not subtracting the same thing every time. If I was subtracting 2 every time, yes, my common difference would be negative 2. But I'm not. So this is not an arithmetic sequence. There is no common difference. Okay, so we can take any sequence and turn it into a table. And that's going to be our big goal now. We're going to take the sequence and we're going to turn it into a table. Now there are some key things that we want to keep in mind here. The x value will be the term number. So if it's my first number in the sequence, my term is 1. And then our y value will be the actual number itself. We can then use the table to write an equation. And that equation then we can use to find any term in the sequence. So we're going to go ahead and we're going to look at, this is my first number here, 5. So in my table, for my first term, I'm going to put 5. My second term is 9, so I'm going to put 9, and then 13, and 17. So my first number is 5, second number is 9, and then 13 and 17. So now what I'm going to do is I'm going to look at how things change. So when I look at here, my x is changing by 1. My y's are changing by adding 4. So my value is, I'm looking at how my y's change over how my x's change, times the term number plus my original value. Now, remember how when we were doing tables, if we didn't have a 0 here, we had to work backwards? So let's work backwards. If I was adding 4 each time, when I work backwards, I'm minus 4, minus 4, minus 4. So what is 5 minus 4? Well, that's going to give me 1. So that means that's my starting value. So every time I'm adding 4, and my original 0 value would have started at 1. And that's my equation. So that's just to find the equation. Now I need to find the 16th term. So I'm going to plug in 16 for x. So y equals 4 times 16 plus 1. Well, 4 times 16, let's see, 4 times 10 is 40, 4 times 6 is 24, 40 plus 24 is 64. So my 16th term should be 65. And that's it. Okay, so let's go to the next one. We're going to write a rule for the sequence, and then we're going to find the 38th term. So I'm going to go ahead and put my first term, my second term, third term, and last term. So it looks like my number values are going down, so I subtract 6, subtract 6, subtract 6, so each time I'm minusing 6. And then I've got to work backwards to find my starting value. So at 0, so the opposite of minus 6 would be add 6, add 6, add 6. So 11 plus 6 gives me 17. And now I'm going to use this equation to find my 38th term. So I'm going to plug in 38 for x. So this is y equals negative 6 times 38 plus 17. And so these are big numbers, so I'm going to have to grab my handy-dandy calculator, or not. Sorry, dropped my calculator there. So let's see, negative 6 times 38 gives me negative 228, and then I'm going to add 17 to that, which gives me negative 211. So my 38th term will be negative 211. Okay. So write the rule for the sequence and find the 40th term. So let's go ahead and put our values in there. So we've got 2, 7, 12, 17. So I'm looking at what I add each time. So each time I'm adding 5. And then I've got to work backwards to find my initial value. So the opposite of adding 5 is minusing 5. So 2 minus 5 gives me negative 3. So my starting value is negative 3. Now I'm going to use that equation to find the 40th term. So y equals 5 times 40 minus 3. So 5 times 40 is 200. And 200 minus 3 gives me 197. Okay. So we can use this idea to kind of help us out with story problems. A bag of cat food weighs 18 pounds at the beginning of day 1. So on day 1, it weighs 18 pounds. Each day, the cats are fed half a pound of food. So on day 2, we're going to go down half a pound. So our bag starts at 18 pounds, and then we lose half a pound, so 17.5. And at 3, we're going to have 17. So if I work backwards now, well, let's start with, what am I doing each time? I'm going down 0.5 pounds. So there's the beginning of my equation. Now I have to work backwards to find that initial starting point. So if I'm going down 0.5, I need to go up 0.5 to give me a starting value. So now we're going to calculate how much does a bag of food weigh at the beginning of day 30. So we're going to go ahead and plug in 30. So y equals negative 0.5 times 30 plus 18.5. So now I'm going to get negative 15 plus 18.5, which tells me that my bag is going to weigh 3.5 pounds. Which makes sense because on my odd days I have an even amount, or a whole number amount of food. So on our even days, we end up with 0.5. So I know that it's going to be a 0.5. So that works out. And so now I have to go ahead and label what is my answer. It's 3.5 pounds of food. Okay. Each time a truck stops, it drops off 150 pounds of cargo. After stop 1, give myself a 0 here, the cargo weighed 2,000 pounds. At stop 2, we're going to be 150 pounds less. So that's going to be, what, 1850? So each time I'm dropping off 150 pounds. And then I need to start with a starting point. So if I'm dropping 150 pounds, to go backwards, I need to add 150 pounds. And now, if I want to figure out how much weight I have at stop 9, I'm going to go ahead and plug in 9. So y equals negative 150 times 9 plus 2150. So again, using that handy dandy calculator, if I don't drop it this time, negative 150 times 9 gives me negative 1350 plus 2150. And so the weight is 800 pounds. So that's it. Using the same ideas, just now with story problems. Giving us an equation to work from to predict at term 1000. So I don't have to sit there and over drop 150, drop 150, drop it. Oh wait, how many did I do so far? Oh no, I have to start all over. So giving us that equation just eliminates that need of having to do that operation over and over and over 30 times or 9 times or whatever. So that's it for chapter 3, and I wish you the best of luck on the test.